pleasant day to everyone. I'm here, Mr. Gilongos, to present to you and explain about the topic Fundamental Theorem of Calculus, or FTC. The Fundamental Theorem of Calculus is very important in evaluating definite integral. This theorem states that if a function f is continuous on the closed interval ab, and f, that is capital F, is an antiderivative of the function f, which is small letter f, on the said interval, then the integral of f of x dx from a to b is equal to f of b minus f of a. So let's have first example. So evaluate using the fundamental theorem of calculus. Integral of quantity 3 minus x dx from 0 to 2. So the solution is the integral of 3 minus x dx using the fundamental theorem of calculus, now from 0 to 2, is equal to f of 2 minus f of 0. Again, f here, capital F, is the antiderivative function of 3 minus x. So how do we find the antiderivative of 3 minus x? So the antiderivative or integral of 3, so whenever we see a constant here, we simply add a variable. So we have integral of 3 is 3x. Okay. So, and the integral of negative x, here we have the exponent 1 here. So using power rule, we add 1 to the given exponent. So the resulting is 2. Then this 2 resulting 2 exponent, we simply divide the given term by the resulting exponent. So that is the integral of negative x is negative x squared over 2. Okay. Then after that, we copy the limits from 0 to 2 is equal to, so the next step here is to evaluate the integral by simply substituting the upper and lower limit respectively. So we have substitute first the upper limit, 3 times 2, so 3 times 2 here is equal to 6, then minus 2 squared over 2, 2 squared is 4, divided by 2 is 2, okay, 3 times 0 is 0, and 0 squared over 2 is also 0. So this term, this part here is just equal to 0. Then finally, 6 minus 2 minus 0 is equal to 4. So the integral of 3 minus x dx from 0 to 2 is equal to 4. We go now to the second example. So example number 2. Again, using the fundamental theorem of calculus, we evaluate the integral of quantity 3x squared minus 4x plus 1 dx from 1 to 4. So the solution is, again, using the fundamental theorem of calculus, the integral of this expression is equal to f of 4 minus f of 1. So how do we find the integral? So here, okay, so let's use pen here. So 3x squared here, again using power rule, so we add 1 to the given exponent, so that's 2 plus 1 is 3. After that, the resulting exponent is 3. We divide the given term by the resulting exponent, so that is 3. And 3 divided by 3 here cancels out. Okay, so that's the integral of 3x squared is equal to x cubed. Okay. Then the next term is the integral of negative 4x, again using power rule. The given exponent is 1 plus 1 here, so that will give us 2. Then we divide the given term by 2, so negative 4 divided by 2 is negative 2. Okay, then last, the integral of positive 1, whenever we integrate a constant, so we simply just add x, no? So 1 times x is 1x. So the integral is x cubed minus 2x squared plus x. Then copy the limits from 1 to 4. The next step is simply substitution. Okay, so we substitute first the upper limit, that is 4 cubed. 4 cubed is 64. Okay, minus 2 times 4 squared. 4 squared is 16 times negative 2, that is negative 32. Then plus x, no? So x here is 4. Okay, so for the second part, we substitute the lower limit, which is 1. So 1 cube is 1. Okay, let's use here a grouping symbol. So 1, then negative 2 times 1 squared is, this is 1 times negative 2 is negative 2, then plus 1. Okay, so we simplify this one. 64 minus 32 is 32, plus 4 is 36, and 1 minus 2 plus 1 is 0. So 36 minus 0 is 36. So here, the integral of 3x squared minus 4x plus 1 dx from 1 to 4 is 36. Okay, then going to our third and last example. So again, evaluate the given integral using definite integral using the fundamental theorem of calculus. We have integral of 2 times quantity x minus 4 cubed dx from 2 to 5. So the solution here is, okay, so again using FTC or fundamental counting principle, fundamental theorem of calculus, we have f of 5 minus f of 2. So we're going to use here a power rule, no? So let's say x minus 4, we add 1 to the given exponents, so 3 plus 1 is 4. Now for that, the resulting exponent is 4, we divide the given term by 4. Okay, so 2 divided by 4 is 1/2. Okay, after that, we copy the limits, no? So you have from 2 to 5. By the way, the integral of our base, which is x minus 4, is just 1, no? So integral of x is 1 and negative 4 is, derivative is 0, 1 and 0. Okay, so next step is to evaluate by substituting the upper and lower limit. So you have 5 minus 4 quantity raised to 4th power divided by 2 minus quantity 2 minus 4 raised to 4th power divided by 2. 5 minus 4 is 1, raised to 4th power is still 1 over 2, and 2 minus 4 is negative 2. Negative 2 raised to 4th power is 16, and 16 divided by 2 is 8. Finally, 1/2 minus 8 is negative 15 over 2. So this is the resulting integral. I hope you find enlightenment in this video. This is the end of the video presentation. So please press like and subscribe to my video. Thank you very much.